Hello friends, in this video we will see question from IC engines useful for AMA, Tspsc or Appsc. These are good questions friends, standard questions which will be useful for your examination. If the approximate average mean pressure during suction, compression, power and exhaust strokes of an IC engine respectively 15 kN per meter square, 15 kilopascals below atmosphere, that means minus pressure, 200 kilonewton per meter square above atmosphere, that means during 15 kilopascals during minus 15 it's a okay, during suction, and compression it is 200 kilopascals, and power stroke it is 1000 kilopascals, and above of course plus, and during exhaust it is 20 kilonewton per meter square, that is kilopascal. So he is asking what is the resultant mean effective pressure. So let us consider suction and what you call exhaust. So the net is 20 minus of minus 15, 35 kilopascals, and during expansion compression it is the net is 1000 minus 200. How much it is? 800 kilopascals. So what is the net, what you call the mean effective pressure? It should be 800 minus 35, that is 765 kilopascals or kilonewton per meter square. Knocking in the SI engine decreases in which one of the following orders of combustion chamber designs? Friends, there are various types of combustion chambers for SI engines. For example, like I head, F head, L head, T head, etc. I head is not given here, friends. Actually, it is going to so where you are exactly you are locating your spark plug, whether it is in the engine cylinder head or the main combustion chamber, or how the valves are being driven, how many camshafts are required for the operation of the valves. So depending upon this, so we have got various classification of the SI engine combustion chambers. He is asking knocking tendency decreasing, okay, order. So it is T head will be having more than, so this will be the decreasing order of the knocking tendency of the different types of combustion chambers, or T head is greater than what you call this is a T head greater than L head greater than F head. So this is the correct answer, friends. So let us mark the answer. T head will be having the maximum knocking tendency, then lesser than this L head, lesser than this F head. That is the correct answer. Next, the curve shows in the figure, given figure is characteristic of engines. So what does y-axis represent? He is asking which parameter is drawn on the y-axis. So x-axis it is given as the power. So is it the efficiency, specific fuel consumption, or air fuel ratio, or total fuel consumption? It is actually, it is a Whelan line, friends. Okay, so this curve is called Whelan's graph. It is basically a graph between what you call the power and total fuel consumption. So if you extrapolate to the negative x-axis, I am going to get the friction horsepower. It is especially used for only diesel engines, friends. So this particular test, Whelan's test, we can find out the friction horsepower for the diesel engines. Okay, this is basically used for diesel engines. Okay, all right. So actually, so the correct answer is total fuel consumption versus power. The correct sequence of the decreasing order of the brake thermal efficiency. What is brake thermal efficiency? It is the brake power by the heat power. Heat power because of the combustion of the fuel, and the brake power, that is power available at the crankshaft. Okay. So now, so he is asking the what you call decreasing order. That means which one is the highest. So like that, next lesser one, next lesser one, next lesser one, something like that. Okay. So here the correct answer is, first of all, the correct answer for this A. So 4-stroke CA engine, then 4-stroke SI engine, then 2-stroke SI engine. So okay, friends. So you are what you call this will be having, yeah, CA engines have highest thermal efficiencies. So he is asking about the thermal efficiency, brake thermal efficiency. CA engines have the highest thermal efficiencies when compared to 4-stroke SI engine. So if there is the comparison between SI and CA engines, so definitely 4-stroke CI engines will be having more thermal efficiency, brake thermal efficiency. Now between the SI engines, two-stroke and four-stroke engines, two-stroke engines will be having, SI engines will be having the more brake thermal efficiency. So the correct order is, it is your A. Four-stroke SI engine, then four-stroke SI engine, then two-stroke SI engine. Yeah, sorry friends. So just if we can change the order. So first of all, this will be having the highest efficiency, then four-stroke SI engine, then two-stroke SI engine. That is the correct answer. Okay. Alright. Four-stroke SI engine will be having more thermal efficiency, back thermal efficiency compared to two-stroke SI engine. Between the SI and C engines, four-stroke SI engine will be having more efficiency than the four-stroke, similar stroke SI engine. So the correct answer is A. In higher, by higher C octane number is the, it is going to give the what you call ignition or the knocking tendency of a particular fuel compared with the reference fuels. Here the reference fuels, primary reference fuels. What are these primary reference fuel with which we are comparing the knocking tendency of a particular fuel under test? It is the let us say percentage of isooctane in a mixture of isooctane and N-heptane. That is going to give the octane number. So here the question is, by higher octane number of SI fuel, SI engine fuel, it is meant that the fuel has which one? Higher heating value or higher flash point or lower volatility or higher ignition delay. The correct answer is longer ignition delay fuels are preferred in SI engines. So this is going to reduce the detonation. Right. Which one of the, actually friends, in the SI engine, the phenomenon of detonation is something different from that of the phenomenon of detonation or knocking in case of a C engine. In case of a C engine, it is a front charge that is near the cylinder wall towards the TDC that is going to what you call detonate first. Then, sorry friends, so it is the last charge, that means the charge near the BDC that is going to detonate compared to the initial charge. But whereas in case of CA engine, it is reverse. That means the charge near the what you call TDC. Okay, let us say for example the extreme position of the TDC, extreme position of the BDC. If you are taking that as the your reference positions, so the fuel what you call the charge diesel air mixture, okay, towards the TDC side. Okay, that means left side near the cylinder wall. So this is going to detonate first compared to the last charge which is going to detonate, that is toward the BDC in case of SI engine. So because of this reversed behavior of the detonation or knocking in SI and CI engines, let us say, so he is asking the question that which one of the following engines, so for the previous question friends, I was referring to the previous questions, low ignition delay fuels are definitely preferred in SI engines. So this is going to reduce the knocking tendency. That's why they are preferred. Now, which one of the following engines will have heavier flywheel than the remaining ones? So here the flywheel consists, the size of the flywheel is going to depend upon the what you call torque variation with respect to the crank angle. If this is more, we have to use a bigger flywheel. So let us see the answer for this. So the correct answer for this particular question is, let us say, so there are actually four options. 40 HP 4-stroke petrol engine running at 1500 rpm, 40 HP 2-stroke petrol engine running at 1500 rpm, then 40 HP 2-stroke diesel engine running at 750 rpm, and 40 HP 4-stroke diesel engine running at 750 rpm. The correct answer is 40 HP 4-stroke diesel engine running at 750 rpm. But why? Actually, diesel engines have higher compression ratio and a turning moment variation in 4-stroke engines. That's why, and this is more than 2-stroke engines. Hence, we go for larger flywheel in case of a 4-stroke diesel engine. That is the correct answer. The correct answer is D. A 2-stroke engine has a speed of 750 rpm. A 4-stroke engine having identical cylinder size runs at 1500 rpm. The theoretical output of the 2-stroke engine. So here we know that friends, actually there are 2 power strokes in case of a 2-stroke engine for one revolution of the For 2 revolutions there will be 2 power strokes in case of 2 stroke engine, but whereas in 4 stroke engine for 2 revolutions of the crankshaft you will have only 1 power stroke. That's why almost the power of the let us say 2 stroke engine is double than the 4 stroke engine of the same size, let us say, right. Right. So here it is approximately something like that. Okay. So nearly 2 times. So here the question is the what is the theoretical output of the comparison of these 2 engines. So this will be same. Okay. By going by the logic which I have discussed just now, so they will be same. The correct answer is C. In a 4-stroke engine, for every 2 revolutions there is 1 power stroke. But in case of a 2-stroke engine, we have got for every 2 revolutions we have got 2 power strokes. That's why your power is doubled. So here also speed is also doubled for 4-stroke engine, and the speed is halved for 2-stroke engine. So this will be balancing. That's why we will have same power. Which of the following types of compressors is mostly used for supercharging of IC engines? So which type of compressors are used for supercharging of IC engines? Okay, is it radial flow compressor, axial flow compressor, root blower, or reciprocating compressor? Here normally, generally friends, so root blower is normally used for the supercharging of the IC engines. Okay friends, right? But why? So for supercharging, low pressure ratios are required. Hence, the type of compressor is a roots blower or vane type compressor. In this, actually, lower pressure ratios are achieved. That's why they are used for supercharging, which is a requirement for supercharging of an IC engine. For same power output and the same compression ratio as compared to 2-stroke engine, 4-stroke engines have. So here he is comparing the various parameters regarding the fuel consumption, thermal efficiency, temperature of the exhaust gases, and of course there is a comparison between lower and higher thermal efficiency. What is the correct answer for this? The correct answer for this is D. That is higher thermal efficiency. But why? Let us see. Right. Okay friends, actually what is going to happen is loss of fuel due to exhaust gases is not there in 4-stroke engines. That's why we've got more higher thermal efficiency. So because actually heat content is very important as far as the engine efficiency is concerned, thermal efficiency is concerned. The more the heat, the more the efficiency. If there are more losses, then definitely the efficiency will be decreasing. Because it is less in case of 4-stroke engines, then definitely they have higher thermal efficiency. That is the correct answer. Let us go for the last question friends. In SI engines, which of the following is the correct order of the fuels with increasing detonation tendency? So paraffins, olefins, naphthenes and aromatics. They are all the petrol derivatives friends. Okay, they are obtained at various levels of the distillery columns when they are actually what you call in the production. Okay, in the distillation columns they will be at each different heights, they will be produced. Right now the question is, so what is the correct order? The correct order of the fuels with increasing detonation tendency. Okay, increasing detonation tendency means, let us say, what is the correct answer? The correct answer is aromatics or SI engine fuels that have highest anti-knock properties. Okay, highest anti-knock properties means less detonating properties. Is it not? Yes. So then comes in the same order. That's why aromatics or SI engine fuels, they have highest anti-knock properties. Paraffins or C engine fuels basically normally, and they have high heating value, and because of larger number of hydrogen atoms. So these paraffins will be having larger number of hydrogen atoms. Hydrogen has the highest calorific value friends. Its value is more compared to various other fuel constituents like carbon, sulfur, your nitrogen, oxygen, etc. But this will be having the highest calorific value because the more number of hydrogen atoms in the C engine fuels, they will be having like paraffins, they will be having highest calorific value or heating value. And now the correct answer is D, aromatics, then naphthenes, then olefins, and then paraffins. This is the increasing detonation tendency. Okay, So friends, in this video we have seen some good questions from the point of view of your examination for TSPSC MBA and APPSC AMBA also, friends. Okay, so I am offering online batches for APPSC AMBA examination, which will be conducted mostly in the month of July last or maybe August first week, as per the going by the what you call social media reports, but we have to verify and cross check from the official notification by the APPSC. If you are interested for online coaching for this particular examination APPSC MBA, you can contact me. Okay, I will be giving my contact number and email ID in the description box. Let us meet in the next video.